Good morning, everyone. Welcome to another episode of Xah Talk Show. Today is 2021, 10 o'clock, 10:30, April 1st. Let's start. So today's topic is going to be technical and random. I gotta put. I have a little bit cross-eye, so let me put my patch on. So now I can see better. So let's start Xah clear recent history, Xah start command log mod. So here on the left window you can see all the command I type. So first of all, go to my Emacs settings, and I need to set a bigger font. So copy that, new buffer, paste it, magnify, go to Xah Emacs list mod and modify this line. If I'm on Windows, set the font to 14 for all buffers. So evaluate it, now it's good. So now if I open any new buffer type, it's gonna be big fonts, okay? So close that. So today I'm going to talk about randomish. Your questions dictate what I'm going to talk about. But okay, so let me begin by Mathematica. Okay, so I want to talk about Mathematica. So questions, comments, post it. Okay, and donate. Don't forget, there's a donate button. You get a dedicated answer if you put money to my pocket. Good morning, Fazing. So I use an eye patch to die to strabismus, double vision. Yeah. So today's topic, I'm going to start to show you some Mathematica because that's my thing. I've been coding quite a lot Mathematica in the past few days because I need to catch up. I haven't been coding Mathematica for 15 years. So I'm going to ask your questions, okay? But let me begin let me continue talking about Mathematica. The Wolfram language, okay, Mathematica, Wolfram Language. So I'm going to give you a quick, very condensed introduction to programmers on how do you program Wolfram language. Okay, now there are 3 steps to learn Wolfram language. It's got 6,000 functions built-in, so it's overwhelming. So first of all, you go to the Wolfram language documentation center, and first step is to use Wolfram language as a graphing calculator. For example, data visualization. You pick whatever category you are interested: sound, visualization, AI, graphics, math, whatever. So let me quickly demonstrate. So you go to any one of these, and let's pick something interesting. Okay, stream plot. Okay, so so if I'm going to talk about this is going to be long. Okay, so copied. So let's go to Wolfram Mathematica. Okay, this is going to be long talk because I was thinking let me just do it fast, but there's so much to talk about. So actually paste that, evaluate. You have to copy the other thing. Shit. List stream plot. Okay, so first of all, delete that. Let's magnify this to 150. Okay, so first of all, you define the data, then list stream plot. Okay, and data. So you got that. So first step is to play with Wolfram language as a fancy graphing calculator. Now the second thing you want to do to master Wolfram language, to get an introduction of Wolfram language, is you read this book, Stefan Wolfram's book. Okay, Wolfram language by Stefan Wolfram tutorial. There are like 50 chapters, and if you are a programmer, you can finish each chapter like in few minutes, in 5 minutes or so. So that's the second thing you want to do. Now the third thing you want to do to master, to really, once you after you get an introduction, good basic understanding, how it looks like, you want to go to this section, core language and structure, and basically read each and every one of these sections. That's how you master Mathematica. Okay, so that's how to learn Mathematica. And let me just also mention, you can get Mathematica for free by buy a Raspberry Pi. It's bundled with Raspberry Pi free. Okay, so but you can only run it on Raspberry Pi, or you can actually download the Wolfram engine, the Wolfram scripting language for free. Yeah, entirely. You just register. So that's how you get Mathematica for free. Okay, so that's about that. That's getting Mathematica for free, and that's how do you learn? How do you master Wolfram language? I mean, yeah, that's the three ways. Okay, follow my steps. Follow this in order. Play with it as a graphing calculator, or then after that, read Stephen Wolfram's introduction book. Then master the Wolfram language section. Okay, now I'm going to start to teach you Wolfram language. Okay, I'm going to go through the basic programming construct about Wolfram language. So first of all, Python tutorial. So for you Python or Lisp programmers, let me just follow my tutorial and I show you how to do it in Wolfram language. So we have Python 3 in 1 hour. Okay, so first of all, let me show you. Let's magnify this. Let's yeah, okay, so now I go to Wolfram language. Yeah, so now I go to how do you master Mathematica. Okay, so actually let's start a new window. So 3 plus 1, let's magnify. Actually I do need this so I can see better. So you evaluate 3 plus 1. So first of all, how do you do strings? Strings is a common thing. So string in Mathematica this is a string. Okay, and you can also use Unicode. So let's see, let's try a Unicode. Hot or a bunch of Unicode. Okay, so make them a string, copy back to Mathematica, paste it. You can see okay, wait, what's going, oh yeah, you got you cannot have, okay, so you cannot have emoji. What's going on? Okay, so you can have string, but what's going on with here? Why is that? Why can't I have the, oh yeah, so I got a syntax error probably. So you can also have emojis as part of the string, any Unicode, Chinese or other languages. So that's how you do string. Now what about quoting string, like raw string? Now Wolfram language doesn't have raw string. Okay, and for example, if you want new line, you cannot do that. Okay, this is wrong. Oh, okay, it works. Yes, it works. So you can also have, for example, tab, the typical Unix C language string. Yeah, so string and tab, I mean new line and tab, just backslash. And what about if you want to have a raw string quote? Now 15 years ago, I don't think you can do that, but I'm not sure today. So let's, let me just skip that. Multi-line string. So like normally you would do, yeah, there is no such feature in Wolfram language, at least 15 years ago, but I don't know about today. So let's look at maybe, okay, let's look at the documentation. Let's see what the Wolfram language possibly it has updated. So string manipulation, let's see, let's click on string manipulation. So that's a string join, string length, string expression. Now this string expression is new. Okay, this is new in what year is this? In 2004. So that's the version, I don't know, 2004. Anyway, let's skip that. Okay, so this is how you do string. So let's move on because there are lots of things. What about string manipulation, like substring length? So length is easy. You just do length. Something. Okay, so string length. Okay, so you need string length, right? ABC. Okay, string length 3. String length, then arithmetics. So arithmetics is easy. 3 plus 3, 3 times 2, 3 divided by a bunch of numbers. It gives you it gives you a fraction, exact numerical result. And if you want numerical result, you can, if the input is numerical, like just put a dot, then it gives you the approximate number for that. So similarly, that's how you do. So for modular arithmetics, so you do mod. Yeah, I think so. So for example, 5 in mod 2, you got 1. Okay, so that's or you can think of that as remainder. 5 divided by 2, you want the remainder. And power is just like that. And Wolfram language also support, okay, let's skip that, true and false. So in Wolfram language, true is by this symbol, okay, and false is false, FALSE. And you have functions like that. For example, if 3 less than 2, then print, let's say, then x, okay, otherwise y. So it's symbolic. So that's how you do if expression. Now in Mathematica, in many languages, true and false, many different values evaluate to false. For example, in Python, 0 is also false, or empty string is also false, or empty list is also false. Now in Wolfram language, there's nothing like that. Only true returns true, and only this symbol false returns false. Otherwise, if you have something Mathematica cannot tell whether it's true or false, you get for example, x less than 3. Is that true or false? So if I evaluate it, it returns that expression by itself. It doesn't change nothing. And this is a feature. This is not a flaw. This is a feature because in Mathematica everything is symbolic. So if you give if x less than 3, if is that true or false? So this is a symbolic result. Now if you set x equals to 2, then you evaluate that again. It will actually give you an answer. So you can this is a feature because you can compute, you can do very long expressions with symbolic items in it. Then So you get a symbolic result. The full, this is actually the answer. The answer of x, whether x is less than 3, is exactly that when x is unknown. So you see that's what this is why it's a feature. You'll know if you do a lot of Mathematica. You'll know later on, because this is useful, because that's this is the actual answer, the symbolic answer if x is unknown. Okay, so that's if and else and true and false. What about loop? Okay, in Mathematica is a functional language. In general, you don't do loops like if, like for loop, while loop. But however, Mathematica is like actually so-called multi-paradigm. You can do any of these procedural construct. For example, let's do a loop. Okay, so do, for example, I equals to 1. Now I forgot what's the syntax for do, but I believe that's it. So I plus plus. Okay, so let's see if that works. I forgot what's the syntax. Okay, that doesn't work. So let's look at documentation for do expression and okay, so this is how you do it. So let's say I from 1 to 10, and each one accumulate. Yeah. Okay, so here is what you do. I from 1 to 9. Okay, I plus plus. Okay, so this will add the summation of what I 1 to 9. Evaluate it. Oh, okay, so do doesn't return a result. Yeah, so you have to evaluate I again. What? So this is a procedural yeah, so you have to return, you have to do this is a procedural, this is how you do procedural programming in Mathematica. You have to say a return. So I plus plus semicolon return I. Okay, what's going on? Oh yeah, so I forgot. Mathematica doesn't do the C-like syntax. This is the way to, everything is in function form. Okay, there you go. So why is it only 2? Expression Imax, yeah, stuck in these uninteresting things. So Fazing has a question, personal question. Do you feel you wasted time with your work on Emacs? That's the impression I got when watching one of your previous streams. Okay, so let me answer that later. Okay. So in general, so how do we? So actually, so let's figure out about the do. Okay, so you can use return break, continue throw, inside loop. Okay, unless an explicit return is used, the value returned by do is null. So why is this not? Yeah, let's just do this. So that works. Okay, so that works. If you say return I here, that's 1. Because any well, this is pretty bad. Basically nobody nobody use do in Mathematica. That's a procedural programming. You can do it, but but I've been coding Mathematica for 10 years. You basically never use it, so I forgot. So anyway, there's also while statement, test and body. So while x less than 10, x print x. Okay, so actually we can use print. This is infinite loop. Shit. Alt dot to cancel Mathematica. Oh, okay. So wait. Yeah. So I got into a infinite loop. Shit. Ah. Infinite loop. Go. So I have to kill it. Okay. Yeah. No, that doesn't work. Have you programmed in Mathematica? You have to have programmed it in it, otherwise you wouldn't know. So okay, so let's open my packages again. Yeah, it's just Wolfram desktop. Concurrent users 14. Okay, so new notebook. So I feel kind of screwed up and boring because I need to get to many of the interesting parts and functional programming about Mathematica, but I'm trying to cover some of the procedural programming construct. Mathematica has all that procedural programming construct you can use, but you can basically, if you are coming from Python or C or Java, those languages, you can use all these constructs and they all work fine. They work perfectly fine. But however, once you started to become familiar with with math Wolfram language, you basically never use these constructs. Okay, so there's a tutorial on procedural programming. So you can see, the Wolfram language stands out from, there's a lot of marketing things. The Wolfram language stands out from traditional computer languages in supporting many programming paradigms. Procedural programming is the only paradigm available in languages like C and Java, as well as most scripting languages. The Wolfram language supports all standard procedural programming constructs. Note the word all, yes, but often extends them through integration into its more general symbolic programming environment. So anyway, so it's telling you basically don't use it. Well, actually, you can use it, but that's not the style if you want explore Mathematica's feature. So you have, if which switch and return throw a catch, print. Those are pretty common from C, and there's also for loop. Okay, let me show you a for loop. For loop, so the syntax is I equals to 1. Okay, I equals 1, test I less than 10. Okay, then increment, let's say 2, then body, let's say print I. Okay, what's going? Wow, Jesus, another infinite loop because I forgot to increment I. Shit. So that's a bad thing about procedural programming. You get into infinite loops. Okay, so Wolfram language, start over. Okay, so there it is. We are back, and let's get the documentation up. So anyway, so you have procedural programming. So what else I want to cover? Actually, I should cover procedure. I really should cover it because otherwise, for beginners, you don't know how to use the others. Because the functional programming constructs for doing loops, you know, you may not be familiar with. So I need to show you the procedures. So when you begin Mathematica, you might as well do all the while loop and do loops. So let's do a for, okay, for loop. So first of all, look up the syntax for loop. And let's just copy it. Yeah, instead of me typing. For example, I start from I equals to 0. Then test is I less than 4. Then increment, I forgot the increment. Then print I. Okay. So any of these, but by the way, any of these can be any of the arguments can be arbitrary big huge expressions. So for example, I can do I squared. So let's cover. So let's just cover the really basics. So you know about for loops, right? So for loops, if you go to so there are two guides. One is all the looping constructs in Mathematica. So if you come from C or Python or Java or JavaScript, you will be familiar with do, while, for, and and throw, break, continue, return, and catch. So that's typically procedural programming languages loop constructs. But you see, this article is about looping constructs. So if you want to do functional programming, you use table. Okay, table is extremely powerful. Let me tell you, for you Python programmers, table is equivalent to Python's so-called list comprehension. Okay, Python list comprehension is idiotic, including Haskell. Okay, Haskell and Python, they think they have the list comprehension construct, basically that allows you to construct nested arrays or nested arrays. That's what list comprehension is. It's available in Python, with a special syntax, basically a language within a language, mini language for this syntax. List comprehension. It's also an idiotic name. And so I have an article on why list comprehension is bad. List comprehension is a little language. It's an exception in syntax and semantics, like who enter here, or rules don't apply. So that's what basically list comprehension is. It's a special mini language within a language that allows you to construct array or nested array. That's what it is. Okay. And in Haskell, it's the same thing, and it's extremely idiotic. In Common Lisp, you have the similar thing. It's called loop. But in Mathematica, the table function actually is similar. Okay, so let me show you. So x, for example, x10. Evaluate, you get an array of 1 to 10. Okay. So now you can say, so instead of 10, let's say 3 to 9. So that gets you from 3 to 9. Okay. Now you can say, let's say 3 to 90 in increment of 5. Okay, so you get the list in increment of 5. Now let's say you want nested. Let me show, table is one of the most general purpose, the most powerful general purpose construct in Mathematica. That is also the most frequently used. So let me take some time to explain the table thing. So you can generate an array. Now let me show you how to generate a nested array. Okay, so let's say 1, 2, 5. Now instead of x, let's say function x and y. Okay, then you say x from 1 to 5 and y from 1 to, let's say, 3. Enter. So you can see you get a nested array of the function. This function is symbolic. Now if you define a function, let's say, let me show you quickly how to define a function. Okay, this is pattern matching. Okay, so this is the most common way to define a function. So let's say f x y takes 2 arguments. It just add them up. Okay, define it. Now if you reevaluate the table thing, you see you got numbers. So table, let's do the table again. Okay, now let's not use f. Let's say list. Okay, so you get a nested list, and it can be arbitrary dimensions. So that's 2 dimensions. So let's add another dimension. X, Y, and Z. Okay, so Z, and you can actually, this part, the first argument to table, can be any arbitrary expression. So let's say x. So first of all, let's just try x, y, z. Okay, that's the simplest. Let's make it 2 so it doesn't. Okay, so here is our function. Here is our wait. Okay, that's when it's purple. That means you have bad syntax, bracket mismatch. So this table function. So this table function returns, let's say x, y. Oh, we forgot z. Let's add z. Okay. So 1, 1, 1, 1, 1, 2. X goes from 1 to 5 in increment of 1. Y goes from 1 to 3 in increment of 1, and z goes to just 1, 2 in increment of 1. So you can see 1, 1, 1, 1, 1, 2. Then 1, 2, 1, 1, 2, 2. Why do we have just 2 elements? Because z, just 2 elements. 1, 2. The last part is 1, 2, 1, 2, and the third part 1, 3, 1, 1, 3, 2. Okay. So let's say let's change z from with increment of 0.2. So you can see 1, 1, 1, and 1, 1, 1.2. 1, 1, 1.4, 1, 1, 1.6. So this is actually 3-dimensional matrix, and you can add different increment for any of x, y, z, or add more dimensions if you want. Okay, and okay, let's run that, and let me show you a matrix form. Okay, so this way it will actually display it in a traditional matrix form. So, and like I said before, x and y, z can be any expression, the first argument. So let's say x plus y plus z. Okay, so you got just numbers. This is a 3-dimensional matrix, and it can be arbitrary complex number expression. Let's say, let's leave it. Okay, so because I don't want to get too complex. So table is the most fundamental and common function to generate a list or nested list, or a tree, or a tree, or a matrix. So what's the next? Okay, let's go back to the Python tutorial. Where is my Python tutorial? Yeah, so true and false, conditional if, that's in Mathematica, loop, iteration. So we have while, we have do loop, we have for loop. Then we have table, which is the most general way to iterate, kind of. So now you come to list. Okay, so the basic data structure of Mathematica. So list is just this is a list, 1, 2, 3. That's a syntax for a list, and okay, so that's that. Okay, so list is the most fundamental data structure in Mathematica, used like 99% of the time, because Mathematica is like in my previous video I've talked about Mathematica. The nature of Mathematica is like Lisp. Okay, the nature of Mathematica is like Lisp. So list is the most fundamental data structure, like used in 90% of the time. In fact, throughout 1990s, Mathematica doesn't have any other data structure except list, not even hash tables, not even associated array. The only thing you have, the data structure, is list. For until maybe 2004, then Mathematica added associated list, hash table, and all that. So why is that? Is that a flaw? No, I don't think so, because that takes some explanation to do. The reason you only have list is that list is the only list is the only data structure that can be represented in a textual form. Programming languages, we are talking about syntax, right? The source code is all syntax. Now, essentially the only of all data structures, list is the most general that can be represented as a text, as sequence of things. But for example, how do you represent a hash table? Well, you just have all you have to do is you just have a nested list where each element is again a list of two elements. The first element and second element. You consider the first element to be the key. You consider the second element to be a key. Now, another requirement for hash table or dictionary, Python dictionary, is that the key must be unique, right? So that seems to contradict. So you are saying this is general, but the key is not unique. Well, the reason for that is that because when you that's a semantic issue. Remember, we are separating syntax and semantics. Whether keys are unique, that's a semantic issue. That's not a syntactical issue. Anyway, so let's skip. So that's how you do list in Mathematica. And we have seen them. All these are actually also lists. If you show them in the normal form, you can see they are lists. So tuple, again, so in many languages you have tuple or vectors or array. In C it's called array. So basically it's just a list where you cannot add elements or take away elements. So again, that come back to why I say list is a general form. So why do you want to add a data structure that's vector, where you actually put a limitation to the language. When you have an array, a C array, or in Emacs Lisp called vector, or in Python called tuple, basically that's a list where you cannot change the length. So in some sense, why do you want to do that? You are actually adding limitation to the language. Okay, so the reason they do that, the reason programming languages do that, which is actually adding a limitation. I mean, if you don't want to increase the length or decrease the length, just don't add element to it. You just don't add an element to it. Don't take away element to it. So why do you have to have a special data type like tuple, vector, array that specifically do not allow you to add or take away elements? The reason is efficiency. You see, these languages, they are concerned, because in order to implement it, because of the memory, because of the hardware, and blah blah blah, and int float, that sort of crap. because of implementation limitation, they created this data structure that does not allow you to add, increase length or decrease length because, implementation limitation. So, so for example, let's get another way to say it is that imagine if you have a very smart compiler like Haskell, Haskell static analysis. So if you look, the compiler will look at your source code, and analyze it, and it will see, oh, you never actually added an element to a list, and you never decreased, taken any elements away. It will automatically compile your list into what Python calls tuple, or C calls array, or Emacs list calls vector. So if you have a smart compiler, that automatically happens. So in other words, the reason these languages have these things because they are computer engineering byproducts. Okay, they are not something needed by the programmer, by the master. They are actually something, they are trying to, the compiler writers trying to implement this thing, and it's a big problem. So instead of trying to solve it, they just throw it up into the language to become a problem for the programmer. So every time when you use Python or Lisp or C, you have to actually decide beforehand whether you are going to add elements or take away elements to the list. That's a thinking. That's a point of view. That's why I say, this tuple, vector or array idea is a byproduct of computer engineering. Because if you want a list that doesn't grow or shrink, you simply don't grow or shrink it. There's no, you don't need to have a special data structure. So that's what I'm saying. So Mathematica, the list is the only necessary and essentially, if you add any data structure other than list, you are actually creating a byproduct of computer engineering, because as a programmer you don't need it. Okay, this is a point of view. Actually, I need to take a lot of time to explain this, because for most people, they hear this, they'll think, oh my god, what kind of bullshit is this? But okay, so yeah, so should it will take some time to go, maybe another day, to go into detail why, this perspective, this kind of perspective. Okay, so anyway, so you see how list is done. But anyway, in Mathematica, I'm not sure. They have actually added data structures that's not just a list. Okay, so we can go back. So you can go. Let's see. So let me show you how do you actually do tuple in Mathematica. Okay, so you go to core language structures, and you go to structure data sets. No, I don't. I think that's much more complex. So anyway, associations. Okay, so this is how you do. This is basically hash table in Mathematica. They are added in year. So let's look at association. They are added in year 2014. Pretty late. 2014. Imagine Mathematica began in 1989, I think. So for the first 15, 20, for the first 25 years, there's no such thing as hash table or dictionary or associate list. In Lisp terminology, there's no such thing, because, like I said, that's what I have been explaining in the past 10 minutes. You don't. It is actually not in certain point of view, in certain essential Mathematica point of view, anything other than a list is redundant. It's not just redundant. It's actually it violates. You are actually anything other than list is actually computer engineering side effect. That's what I'm trying to say. Okay, so but in 2015, in 2014, after 25 years, they added association list, so that I suppose so that it's convenient for programmers, because Wolfram language is growing, and just like why Wolfram language has do for loop, while loop, they and increment, plus plus, they added those so that it's more compatible, convenient. So that's okay. So that's what I'm saying. So let's go back to association. So I believe they also added tuples. Okay, so let's see. Now I need to go to a page, documentation page, where they talk about data structures. Let's see, structured data set. Okay. So they added quite a few. All these are new. Okay, all these are new since they were added in the past 10 or 20 years. Data set, a general hierarchical data set containing nested lists and associations. Okay. I believe they added tuple, but I'm not sure where is it. So let's see. So you go to the documentation page, data manipulation and analysis. Let's see, structured data set. No, not that. Structured data set is something much more complex. I'm not sure it even exists in most languages. Let's see. Okay, let's see what. Wait, database connectivity, data manipulation and analysis, structured data sets. So what are they? Data set. Let's see. Okay, so actually, I'm not sure what's the purpose of data set. Apparently, it looks to me it's just a mixed nested list or associations, associated array. I'm not sure why you need a special function to represent that. So data set is new in 2014. Yeah, so it's new in 2014. It's not essential. Okay, so query represents a query that can be applied to a dataset object in which successive operators are applied successively. Okay, that's also new. Okay, I'm not sure where is tuple. Okay, so let's see tuple. Yeah, there it is, tuples. Okay, so this yeah, so I don't think Wolfram language has tuple. Now this function tuples actually gives you basically combinatorics. Okay, so tuple 1 2 3, take two at a time. Oh, tuples. Okay, tuples. Yeah, so it gives you all possible combinations of two items from this list. So that's not the tuple. I don't. So like I said before, there's no such data structure that limits you to just you cannot add elements like C array or Emac list vector or Python tuple. Okay, so that's about data structure. So let's see. So tuple, Python sequence types, we can skip that. So dictionary in Wolfram language is just let's skip that. Okay, so how am I doing? So actually, how long have I been talking? I've been talking for 50 minutes. I haven't got to the many very interesting things yet. So you have a module. You can also have a module. Or basically, how do you use libraries in Wolfram language? And how do you define a function in Wolfram language? How do you define a class and object? Wolfram language doesn't have class and object. Not in the, well, you can easily create them. Object oriented thing. Uh, Oh, okay. Sid Ali. Sid Ali is aged like me. You have to say that because otherwise I thought, oh, you guys are young teenagers, 20 years something. Wolfram language. So you have to look. Yeah. So one of the common question is, and that's also a problem for Wolfram research. Wolfram language. So Wolfram language, most people think of Wolfram language, or they think of it as a application like Mathematica. Okay, where's my? So most people, when most people see Wolfram language, they just think, oh, it's just like a fancy graphing calculator. You can do lots of these. Oh, this I showed the other day. Let me show you something else. Okay, function graph plot. So this plots arbitrary graph. Yeah. Function visualization. Let's see. Function visualization. This is more interesting. So most people think of Wolfram language as a just like fancy application. You can solve equations, do derivatives, integrals, and just compute. And you don't people don't think of it as a programming language. But that's what it is. Okay, so like in my previous video, I did like 4 videos about Wolfram language. You should watch them in the past month. I mentioned how Wolfram language is basically like a Lisp language. Okay, the reason programmers don't don't program it as like a programming language, most people don't use it because there are 2 reasons for that. The first reason is that in the 1990s, Wolfram language is created mostly for mathematicians and physicists. Okay, so they are not programmers in general. They know physics and they know mathematics. They need, because, and also in engineering, material science, chemistry, going a rocket, creating a rocket, sending people to Mars, building, designing a car engine and things like that. You need a lot of mathematics. So engineering, physics, chemistry, hard sciences. These people use Wolfram language, Mathematica, as a tool to design, solve problems. Now these people are not programmers, but they might do a little programming, like how when you use CAD, AutoCAD or 3D modeling, those people have a scripting language built in so that you can do some scripting. But in general, they are not programmers. Programmers is like in a different industry. Programmers, Stephen Wolfram wrote Mathematica in C language. So programmers, they create software. So because of the audience of Mathematica users, physicists and mathematicians and engineers, they are not programmers. So that is why Wolfram Mathematica is seen as a tool. That's these people use. Then, so now let's go to after year 2000s, or after year 2010. You begin to have lots of languages. For example, the language R, and the language MATLAB. Those again, those just like Mathematica, they are math-oriented languages. So do programmers know about them? Not really. So programmers don't, they might think of R is a language to do science, just like Mathematica. But most industrial programmers never coded R or MATLAB. So again, so that is why programmers usually don't know. I mean, if you are in college, you might have, when you study math or physics, maybe you used Mathematica, but not for, as a programming language. Same thing for the language R and Julia. I mean R and MATLAB. These are popular. Now, going to let's jump to 2010. Beginning around 2010, there's a lot of artificial intelligence programming, began by Google and Facebook and so on. Machine learning, big data, science data, visualization. So that's when programmers started. So that's when programmers and mathematicians or statisticians started to mix. So you have some, you started to have a lot of mathematicians or engineers, so they also needs to be proficient programmers. And for machine learning, because you have massive amount of data, and you need to know mathematics, statistics especially, to do neural networks, machine learning stuff. So and programmers, started to, because, for example, you work at Google, then suddenly you have lots of data. You need to begin to learn statistics to do, you are not just coding. You need to know mathematics. That's why there's kind of a merge. So when this happened, most people, for example, Python become very popular in data sciences, massive data and stuff. And also a lot of programmers started to learn R or MATLAB or Julia. Julia is a new language, math-oriented language. OBS Studio reconnection successful. Okay, I think maybe that's it for today. I kind of rambled a lot. 15 people still watching. Oh, I need to answer some questions. Yeah, so after year 2010, people begin, there's a merge of programmers and mathematicians or engineers, and Python becomes very popular. Part of the reason is because of that. What about Mathematica? Mathematica is still, because since year 2000 there's a movement of open source. Now, because Mathematica is not open source, so that kind of cut off, the opportunity, a lot of people, for knowing Wolfram language, because for many of these open source fanatics, when they see something that's not open source, they will not use it. So that, especially programmers. So again, especially programmers, not physicists, not mathematicians, not engineers, because for those people, there's very little open source tools. For example, MATLAB is not free. R is free. Okay. Anyway, so among programmers in particular, they have, you have a lot of people who became open source fanatics. So they don't, they blind themselves. They don't see anything that's not open source. They don't understand. They don't see it. They close the door on themselves. So what they see, they might know about R, they might know about Python, but they wouldn't know anything about MATLAB or Mathematica, for example. I mean, the general trend. So that is the reason. That is the reason programmers still don't know Mathematica is a kind of very powerful programming language. That's my explanation. Okay, when I did my undergrad in computer science not too long ago, remember being confused by the fact that a senior of mine used Mathematica for his thesis. Okay, yeah. So let me answer some of the Bart has a question. Bart, are you still here? So Bart's question is So two questions. Okay, first question, Bart, what do you think about Richard Stallman question? Richard Stallman situation. Okay, for that it's really easy. Okay, you just go to uh, my website, search for Ergo Emacs Richard Stallman. So you can see I have quite a lot of articles about Richard Stallman. Now, if you scroll down, once you find any Richard Stallman article, you just scroll down. There is a index of essentially lots of articles about Richard Stallman. He has created lots of dramas. So in 2009, Richard Stallman resigned from Free Software Foundation. Okay, 2019 September. So I have kind of collected all sort of things. I tells you the story why why is he resigned. He got pushed off, basically, not willingly. He got essentially forced to resign. So I have an article on that. I logged some of the details and also some of my opinions. So this article you should go read. Okay, but go read this article, and I talked about it before. Now, of course, you are asking, you probably are asking what's my opinion about the current situation, because Richard Stallman apparently he he said he's becoming Free Software Foundation leader again, and then there's a lot of controversy because some people don't like him. So I don't agree. Okay, I think those people are not good people. I think those people are bad people. However, Richard Stallman himself, he has not in my opinion, Richard Stallman has done nothing wrong, absolutely nothing to for this incident. However, on a separate issue, Richard Stallman has become problematic because he has not been coding for like 20 years, 10 or 20, probably 20. He has not been coding for 20 years, and his personal life is like secluded from the real world. He become one of those new age guru. Like he tells you, like he can fly. He became a guru, like some India yoga, guru. He he sits there, do nothing every day, and gets donation because people think he's a god. You can see a lot of that in memes. Richard Stallman. So, and he has become, secluded, out of touch with reality. He have no idea what is going on in programming industry. No idea at all. But especially you watch a lot of my videos, but you should know I have quite a lot collection of articles on Richard Stallman of the things he done that is wrong. Okay, so he become out of touch and saying stupid, idiotic things that does great harm to Emacs, the progress of Emacs. So for this reason, I'm not sure he's a good, he should, lead free software. He's got problems. On the other hand, if he leaves free software, the free software is going to be something else. I'm absolutely certain of that. Free Software Foundation without Richard Stallman, whatever problem he has, Richard Stallman is problematic. But however, once he's gone, like he has been removed for a while now, the free software is the nature of Free Software Foundation, and Emacs is already changed. It's gonna be something else. Okay, it's gonna be something else. I would not want to touch. I don't want to touch it. You don't know. I don't know what will happen. Meanwhile, he himself is not a good leader. He shouldn't be. He does not fit. He does not deserve to be our leader anymore for Emacs or for Free Software Foundation. I don't believe so. And also, I would say he has become weak, a weak person. Because due to the incident in 2019, he just I resign. He's become weak. He does not deserve to be our leader. So I don't know. So as far as I'm concerned, the Free Software Foundation is already dead. Like doesn't matter whether with Richard Stallman or without. It's like irrelevant. It becomes some kind of entity, like many of the political non-profit organizations. It becomes just an entity that gets lots of your money, donation, and they do things. They do things that's harmful for humanity, for the good of humanity. That's my opinion, Bart. So Bart's second question: What do you think of people? What do you think of people using OOP languages to program in functional style? Okay, that's first of all, many OOP languages, they do not support functional programming. Maybe a little bit, not much. You cannot do much with it. For example, Perl, Java, Python. Okay, let me just pick these three examples. These three examples are the worst. Okay, now Perl, for example, Perl, they say they are multi-paradigm. Lots of these language, they claim they are multi-paradigm, Perl and Python. But actually, no. If you use Perl, if you are a functional programmer like me, I'm a functional programmer. I love functional programming. I will never code anything OOP in my own project unless I work at, at a job where they already have a software. It's already written. The code is using OOP. Then you do OOP. In my own code, there's not one single line of object-oriented programming. I think that's very well. Actually, sometimes it's useful, but personally, I think it's no good. And in general, it's no good. Okay, so I make two claims. In general, OOP paradigm, OOP style programming is shit. Now, this is my claim. Its value in programming industry is overhyped by far too much. It has only sometimes useful. Okay, that's my claim. So OOP is shit. OOP language is shit, such as Java and Python, especially Java and Python. So then why is a lot of people crazy for OOP? For example, Java, Python, or even JavaScript. Most vast majority of JavaScript code is OOP. How do I conciliate? How do I resolve that? What's my answer? Look, all these people, you must be wrong because all these people, many of them are smart programmers. They are doing OOP. What's my response? My response is look at religion. Okay, there are millions of people who believe in God. There are millions of people who believe in some kind of code. Scientology, Falun Gong, and many others. They believe people can fly. And there are a lot of people, millions, literally millions of people who believe in people can, parapsychology, psychokinesis. They can, they can bend spoons. Okay, there are literally millions of people believing in that. That is my response. Why so many people believe in OOP? Okay, it's just and also a lot of people believe in Chinese medicine. They believe you don't need surgery. Okay, Chinese medicine is a big thing. It's a cultural part of it. So that's my answer. So why most people believe in OOP, and meanwhile I say OOP is like of little value? Well, culture, okay, cultural reasons, programmers, okay. So I don't believe in OOP, and my personal code, I don't code OOP at all. I do functional programming. So let me go back to the so many languages, especially Java. Java is just pure OOP language, okay. In Java language, Java don't even claim they are multi-paradigm. Java is pretty much a pure OOP language. So if you code in such language, basically you cannot do functional programming. You can do a little bit. I believe Java 10 years ago started to support Lambda. Yeah, but the whole thing is OOP. Okay, you cannot do it. Now, for Perl and Python, they both claim to be multi-paradigm. That's bullshit. If you talk to Perl people and Python people, some of the fanatics, they'll say, oh yeah, we can do everything OOP, functional programming can do. No, actually, that's not true. Perl, the nature of Perl is a procedural language. They do not actually support OOP, nor do they support functional programming. Okay, they do support somewhat, but you are kind of forcing it. Okay, so Perl is mostly a procedural language, like assignment procedural, or sometimes called imperative language. It does support OOP and it does support functional programming. I would say pretty well. Okay, but it's like hack. Okay. Now, for Python case, Python is mostly a OOP language. Okay, Python is mostly a OOP language. It claims to support functional programming, but it's like a lie. Because if you are a functional programmer, you run into lots of problems. It cannot do. The most obvious problem is that the most patently obvious shortcoming is that its lambda, the function, is like crippled. Okay, I have an article. Just search for XahTV Python lambda. I have quite a few articles on that. Okay, so I have like 3 articles. So lambda in Python 3000. This is when Guido von Rossum trying to create Python 3, claiming something something something. And here's another important article. Why Python lambda is broken and cannot be fixed. Now, this is a critical article. First of all, I give you some scheme Lisp expert's opinion. He's saying the same thing. Python lambda is no good. Is cripples. Makes Python not a functional language at all. Then I also give the opinion that a critical opinion where the syntax, the Python lambda, why Python cannot do lambda well, or it cannot do functional programming, because the syntax, because the layout, the layout syntax, the tab, that the syntax actually creates a limitation. This is the core reason. This is the gist. This is the essential reason Python lambda cannot be fixed. Not because of a decision by Guido. Rather, it's because the Python syntax created a limitation that makes Python lambda impossible, difficult or inconvenient to be a full lambda. Therefore, once if you have a language whose lambda is kind of crippled, then your language basically cannot do functional programming well. So I'm saying this. The context, I'm saying this because a lot of people think that syntax is not important. They think that semantic is more important in a programming language. They think that syntax can be just arbitrary. Meanwhile, the semantics can be created can be designed to do any type of language. That is false. Okay. The reason I'm saying this is important because it has to do with the common misconception where syntax is not important. In the Python case, Python cannot be a functional language or can never become a fully functional programming language. It's because the Python syntax created a limitation. That is my claim. Okay, and you can read my articles for the details. So answer the question, what do you think of people using OOP languages to program in functional style? First of all, many languages just cannot do it. So Java cannot do it, period. For Perl and Python, you kind of can do it. You can try to push it, but it's not satisfactory. If you are really a functional programmer, it doesn't work well. Okay, so that's my answer. So Fazin's question, I have a question. So you guys donate, okay? Put money. I'm gonna answer your question. So Vazin's question, I have a somewhat a personal question. Do you feel you wasted with your work in Emacs? That's the impression I got watching one of your previous streams. Well, the answer is yes and no. Okay, so you live your life. You made some. I'm 52, so I'm kind of a bit old than most of you, I guess. So if you are young, so anyway, you live your life. During your life, you have made some choices, and in my life, I spent like 20 years devoted to Emacs. Okay, I made some choices. I spend my life in the Unix community, not Windows and not Mac either. I use a Mac, but mostly all the programming language I know, the technology is around Unix, Linux, Python, all the open source, Bash and so on. So in your life, you made some decisions, and so do I regret spend my time in Emacs or Unix? Yes and no. Okay, I cannot say I regret it. Because it's a choice I made. On the other hand, I could, if I might say, I might have a better life if I was not a so much open source, in a hacker community that much. If I actually focused on creating software, doesn't matter what platform, if I focus on creating software, then I might be better off, or study mathematics. If I focus on my life on studying mathematics or creating software, I might have a better life, or better life. I might be happier today. So that is my in retrospect. It's always easy to look back and criticize. If I start over, maybe I'll have a better life, but maybe not. Okay, so that might be something to think about. So because I spent a lot of time when you are in the Unix community, you also tend to be the kind of person, open source fanatics. And also for me, for example, arguing about programming languages. So I spent half of my life, basically a few hours every day to debate with people about programming languages, about Linux, about which operating system to use, this sort of thing. And this is kind of the main thing among hackers. Okay, it's a waste of time. Okay, so it is, and it has in a sense, it has done damage to my life in retrospect, but not necessarily so, because otherwise I wouldn't be who I am. If I didn't, anyway. So that's my kind of opinion. So Paul Edward says, isn't Perl and JavaScript based on the lambda calculus? No, far from it. What are you talking about? C++ has a lambda function as well, but yes, I have only used them as procedural. Yeah, see, the functional programming has a long history, beginning in 1980s, even 1960s. Okay, Lisp is the first functional programming language. Now, of course, for you young people here today, the concept of functional language is different from older people, because for you guys today's new young people, you might think, oh, Haskell is a functional language because no side effect. You have pure Haskell. You don't allow side effect. You don't have mutable variables and all that. It's pure. And OCaml, basically there are not many. Pascal is almost the only pure functional language. Then OCaml, and but today's young people, when you look at this, you might think, oh, that's not functional language at all because you have lots of variables, and in fact lots of global variables, and you change them all the time in this. Okay, so today's people, you might think only Haskell or something like Haskell is functional. That's not true. Okay, functional programming began, Lisp is actually the first one in 1960s. Then there's Camel, the father of Camel is Camel. The father of Camel is, the Camel is called meta language. Okay, then there's a few others. Okay, there are a few others. And anyway, Lisp is the father of functional language. Okay, so uh, so functional, functional. Why is functional language not popular before? Except this was very popular in 1980s. Well, one of the reasons is because functional language is one, hard to implement. Okay, C and similar. C is the fuck. C is extremely easy to implement. Like if you are an idiot, you can implement C. Okay, if you don't have a brain, you can implement C. And if you don't have a brain, you can code C. Now, if you want to implement a functional language like this, it's harder. It's much more harder. Okay, memory management and all sort of things that becomes everywhere today. That becomes in every language. So that is why C becomes very popular. It's like some people say it's a virus. It's the worst shit possible virus. Then some people try to improve it incrementally. So this snake oil seller, the C++ guy. Oh, C is very popular, and C. Oh, I'll just add this a little bit thing to fix C. So that's why C++ is created. Then another guy comes in. Oh, I'll just actually I think this way is better. Let me just fix C. Trick this and trick that. Then you have Java. Okay, C++ Java. Then another guy comes in. Oh, I'll just actually trick this thing. I think it will be better. Then you got D, the language D. Okay, which is also object oriented. So they are all crap. Okay, they are all based on the C, the worst shit. That's why is C popular, because it's the most easy idiotic language to implement. This doesn't require design, no design. That doesn't require a brain. Okay, if you want to do anything different, that's difficult. That's more difficult. But anyway, there's a problem with functional programming because to run Lisp requires lots of memory resources and it's super slow. So if you want artificial intelligence, yeah, you can do that, but the code is very slow. So this is the reason functional programming is not popular. But beginning in 2000, around around let's say just 2010, because the CPU, the hardware becomes very faster and faster, and we have multi-cores now. So because of that, one chip doesn't get faster anymore. You have multi-core. So there are two primary push for functional programming. One is that the hardware becomes very fast and lots of memory. Memory is very cheap, today. So functional programming actually works now. So Haskell becomes super popular, and for example, Clojure as well. So that's why functional programming and JavaScript, okay, it becomes to be very popular. Programmers started to know, oh, Lambda, oh, we should have Lambda, and Java added Lambda, then C++ added Lambda. Okay, they begin to become popular in 2010. The other reason functional programming started to spread among industry programmers is that the chips don't get faster anymore. So what you need is parallel computation. You need parallel algorithms, and in order to do that, in order to write parallel algorithms, functional programming where a function without side effect is extremely helpful because, well, anyway, just take my words for it. It's because because otherwise it's hard to deal with concurrency. Okay, so you want functional programming. So for these two reasons, functional programming become popular, and they got added to Java in 2008, I think, or 2010. Then I added to C in 2020. Okay, that's concludes my talk today. Okay, today is a super long rant, I guess. 1 hour and 25 minutes. Okay, if you like my stuff, donate. Okay, Patreon me, PayPal me, buy my JavaScript tutorial, buy my Emacs tutorial. Just search for XahTV JavaScript, XahTV Emacs list. Thank you guys. Bye.